Hi guys, Dr. B here. So this is a re-lecture or a lecture over resolving and breaking a single vector. We covered this in class already, but in case you missed the lecture or if you're still unsure how to use it or how to do it, this is for you to use. So breaking a single vector into two components, the important thing to recognize and remember or to know about this is that looking at figure 11, well, according to the book I got it from, figure 11, you're dealing with right triangles right now. Right triangles means you are going to be using the Pythagorean theorem eventually, and also SOHCAHTOA, which is something you should already know from last year. So to break a single vector, really quick before we get into that, this is our kind of a subtle introduction into two-dimensional motion. For the most part, we've just been going back and then forth, like that, or forward and forward, etc. Now we are taking angles into consideration. This is not that bad. It's very doable. Just follow along. So to find a vector's components, you need to use the following two formulas. The x component, meaning on a xy axis. The x component is the horizontal one, and that means you got to take cosine into consideration. And the y component is the y component is the sine function. So this b right here is the vector that you're going to be given in the problem, and the theta is the angle you're going to be given in the problem. So let's look at a few, and then we'll be good to go. So suppose you're walking away from the origin. Remember the origin in an xy coordinate plane is 0, 0. That's just something to keep in mind. So now let's say, looking at this, it's horrible, that you are now 5.0 kilometers at an angle of 45 degrees. So this means you're on this is called a resultant vector, and we'll get into that in the next concept. So we're trying to find the vector coordinates, or resolving, that's a term we use. To resolve the vector coordinates, if it says vector coordinates like that, I'm talking about x and y. So we're looking for, I'll do different colors. We're trying to find this one, which is your x vector coordinate, and then this one, will be your y coordinate. So the x coordinate you would find is Vx equals your vector 5.0 times the cosine of your angle, of your theta, so 45. So 5 cosine 45 is 3.53 something something, 2 sig fig, so this will be 3.5. Vy is going to be 5.0 sine 45 equals also 3.53 dot dot dot. 2 sig fig, so it will be 3.5. I should have made it that this color. So your final answer, how it's going to look, is this. So keep in mind that we're on an xy plane, coordinates and all that. So you're going to make your x component, it's going to be written out 3.53. Your y coordinate component, 3.5. Then 3.5 for the y, close parentheses, and then the units you're given in the problem, km. So before I move on, I should have said this before, you have to make sure that your calculator is in degrees for this to work out. I don't know which calculators you all have, but if you have a TI 83, 84, look for the mode button and then change radians to degrees. If you have any problems with that, please email me or let me know and I can help you with that. So resolve a vector 3 meters long at 15 degrees into its components. So what this is saying is that on XY plane, your vector is approximately 3.0 meters long, and the angle is 15 degrees. And I'm trying to find my x component and my y component. So Vx equals my vector 3.0 cosine 15. My y component is my sine, so 3.0 sine 15. My x component is 3 cosine 15, and you should get 2.8977 dot dot dot. My y component is 3 sine 15, and I should be getting 0.7764 dot dot dot. So my answer, my x component is, with the sig figs, is 2.9, comma, then my y component is 0.78, close parentheses, and then my units in the problem is meters. Then box it in. I do this like this to make sure that you can see where the numbers are going, etc. Find the component velocities, so x and y, of a helicopter traveling at 95 kilometers per hour at an angle of 35 degrees to the ground. So just to kind of make sure we understand where we're at. So from 35 degrees, it's an approximation obviously, it is 95 kilometers per hour. I want to find my y component and my x component. So really quick, Vx equals 95 cosine theta with 35. My y component is 95 sine 35. I do my work. I end up with 95 cosine 35. Sorry about that. I didn't mean to do that at all. Is 77. Oops, wrong color. 77.819. My y component, 95 sine 35 was 54.48 dot dot dot. My answer is going to be 78, comma 54, close parentheses, and then my units, kilometers per hour. Notice how it's a different unit than the previous one. Last one. So how fast must a truck travel to stay beneath an airplane that is moving 105 kilometers per hour at an angle of 25 degrees? So this is like, what this is saying is, let's say that they're filming a movie and the airplane is expected to go 25 degrees from the ground and also be traveling at 105 kilometers per hour. And to film, for example, they want to get the underside of the plane. I don't know. The plane and the truck need to be matching up. So the truck is traveling only on the x-axis. It's not going vertical. So we need the Vx. So because a truck can't travel vertically, at least not yet at least. So we're not looking for this, we're just looking for the x component. So Vx equals 105 cosine 25. So 100 cosine 25 is 95.16. So then 3 sig figs, 95.2, my units kilometers per hour. So we're done for this. If you have any questions, let me know.